In 1969, when the Apollo astronauts first stepped onto the lunar surface, they expected to encounter dust. What they found instead was something that acted like it had a mind of its own. The moment astronauts made contact with the surface, fine grey particles began attaching themselves to everything: boots, gloves, helmets, equipment. No amount of brushing could remove it. The dust embedded itself into fabric fibers, scratched protective visors, and somehow found its way inside sealed compartments of the lunar module. Neil Armstrong reported that the dust had a distinct smell like burnt gunpowder. This detail sent scientists into a panic because nothing burns on the moon. There's no oxygen, no atmosphere, no way for combustion to occur. So why would airless, lifeless dust smell like something that had been ignited? When samples reached Earth laboratories, the mystery deepened. The moment lunar dust made contact with our atmosphere, it began reacting violently. Particles would fizz, spark, and fuse together as if they had been waiting billions of years for this exact moment. Some grains generated small electrical discharges. Others seemed to move on their own, crawling across surfaces and reattaching themselves to equipment. Scientists discovered that each grain of lunar dust carried an electrical charge built up over eons of solar radiation bombardment. But even after neutralizing these charges, the dust continued to behave in ways that violated basic chemistry. It contained glass shards sharp enough at the nanometer level to slice through advanced filtration systems. It clumped together in formations that suggested magnetic properties, yet it wasn't magnetic in any conventional sense. The most unsettling observation came from researchers who noticed the dust seemed to respond to environmental changes. Temperature fluctuations, humidity levels, even electromagnetic fields would cause the particles to shift and reorganize themselves. It was as if the dust possessed some kind of primitive awareness of its surroundings. The official explanation centers on the unique atomic structure, created by constant micrometeorite bombardment and solar wind exposure. But the behavioral patterns observed in lunar dust samples continue to puzzle scientists decades later. Some have quietly suggested that the material exhibits properties more consistent with a complex system than simple geological debris. Moving from the Moon to Mars, NASA encountered another substance that appears to laugh in the face of established physics. Martian meteorites, chunks of the red planet blasted into space by massive impacts and eventually collected on Earth, contain isotopic signatures that should be impossible. Radioactive decay follows strict mathematical laws throughout the universe. Elements break down at predictable rates unaffected by external conditions. This principle allows scientists to determine the age of rocks, fossils, and planetary materials with remarkable accuracy. Martian meteorites decided to ignore these rules entirely. When researchers analyzed samples using standard isotopic dating methods, they discovered something that broke their instruments and their understanding of atomic physics. Parts of the same rock showed ages separated by billions of years. Some isotopes appeared to have reset their decay clocks multiple times, while others seemed frozen in temporal stasis. The chemical composition suggested these rocks were ancient, formed during Mars's earliest geological periods. Yet certain isotopes within the same samples appeared virtually new, as if they had just finished forming yesterday. This temporal contradiction shouldn't exist anywhere in the universe. Scientists have proposed several theories to explain this anomaly. Perhaps Mars experienced cosmic radiation events far beyond anything recorded in our solar system. Maybe the planet's unstable magnetic field, which flips and disappears irregularly, once generated energy surges capable of scrambling atomic structure at the subatomic level. The most disturbing possibility is that Mars underwent geological or electrical events, operating on scales we cannot comprehend. Some meteorite samples contain crystal formations that appear to have been heated and cooled simultaneously, suggesting exposure to forces that could manipulate time itself at the atomic level. These Martian samples tell a story that doesn't fit our textbooks. They suggest that on Mars, the fundamental constants of physics might operate differently, that decay rates, atomic stability, and even the flow of time itself might be variables rather than constants. From Mars, we travel to the asteroid belt, where NASA discovered metal that challenges everything we understand about natural formation processes. In the depths of space, floating among countless chunks of rock and ice, lies asteroid Psyche. This metallic world contains materials that shouldn't be possible without deliberate engineering. When fragments of Psyche-type asteroids crashed to Earth and were eventually analyzed, researchers found alloys with perfect ratios of nickel and iron. The crystalline structure was flawless, showing patterns more consistent with manufactured materials than geological formation. The atomic arrangement was so precise, it looked like someone had designed it in a laboratory using advanced metallurgical techniques. Even stranger, the metal exhibited magnetic properties that defied conventional understanding. It would attract magnetic fields one moment, then repel them the next, as if it possessed memory or awareness of electromagnetic changes. Some fragments generated small electrical currents when exposed to radiation, behaving like microscopic power cells embedded within the metal matrix. NASA classified these materials as non-terrestrial structured metal, which is essentially scientific code for admitting they have no explanation for what they're looking at. The uniformity and perfection of the atomic structure suggests formation processes that don't exist in nature, at least not as we understand it. The implications are staggering. If random cosmic processes can create materials more perfect than our best engineering, then either we fundamentally misunderstand how matter forms in space, or we're looking at something that was deliberately manufactured by forces beyond our comprehension. These discoveries from the Moon, Mars, and the asteroid belt represent just the beginning of our journey through NASA's most impossible findings. Each sample, each measurement, each anomaly builds a picture of a universe that operates according to rules we're only beginning to glimpse. What connects these discoveries isn't just their impossibility, but their consistency in demonstrating that our understanding of physics might be far more limited than we've assumed. The dust that acts alive, the rocks that age backwards, and the metal that behaves like technology all point to the same unsettling conclusion. The universe is stranger, more complex, and more mysterious than our current science allows us to acknowledge. And NASA has the samples to prove it. But these earthbound discoveries pale in comparison to what NASA found floating between the stars themselves. When the Stardust mission returned to Earth in 2006, it carried particles that had been drifting through interstellar space for billions of years. These microscopic grains were supposed to be simple cosmic debris, remnants of ancient stellar explosions that would help scientists understand how stars form and die. Instead, they brought back materials that appear to have been manufactured in a universe that follows different rules than ours. Under electron microscopes, these interstellar particles revealed crystalline structures that should be thermodynamically impossible. Some grains contain materials that could only form at temperatures near absolute zero, while other sections of the same particle showed evidence of formation at stellar core temperatures exceeding millions of degrees. It was like finding ice cubes that had been forged in the heart of a star. The isotopic ratios within these particles matched no known stellar processes. Elements were arranged in perfectly repeating patterns that suggested deliberate organization, while other sections appeared completely random, as if chaos and order had been frozen together in the same tiny speck of matter. When researchers attempted to heat one of these particles in laboratory conditions, something extraordinary happened. Instead of melting or changing phase like normal matter, the particle began emitting bursts of infrared radiation, as if it were actively resisting the temperature change. It was behaving more like a microscopic machine than a piece of cosmic dust. NASA scientists had to completely revise their models for how matter behaves in the vacuum of deep space. These particles suggested that between the stars, in regions where matter drifts for eons without interference, physics might operate according to principles we've never encountered on Earth or in our solar system. Some astronomers theorize that these grains might be fragments from the debris field of a collapsed star, material that had been compressed under gravitational forces so intense they rewrote the fundamental rules of atomic behavior. Others quietly suggested something more disturbing, that these particles might have originated outside our galaxy entirely, in regions where the constants of physics themselves might be different. Whatever their origin, these interstellar visitors proved that not everything floating through space follows the same physical laws we observe here on Earth. They're evidence that our universe might be far less uniform than we've assumed, with pockets of reality operating on entirely different versions of physics. While these particles challenged our understanding of matter itself, another NASA discovery was busy breaking the rules of energy and motion in ways that continue to baffle scientists today. When Voyager 1 crossed the boundary of our solar system and entered interstellar space, it was supposed to drift quietly into the cosmic void, sending back routine measurements until its power finally failed. Instead, the probe began detecting phenomena that don't appear in any physics textbook. At the edge of our solar system, Voyager encountered a low-frequency vibration, a background hum that permeates the space between stars. This wasn't cosmic radiation or solar wind interference. It was something else entirely, a constant oscillation that seemed to be the heartbeat of empty space itself. The frequency didn't match any known natural source in the universe. Even more puzzling, as Voyager moved further from our Sun, the energy signature began shifting and changing, as if it were interacting with invisible structures that shouldn't exist in the vacuum of space. Voyager's magnetic sensors began picking up tiny fluctuations that defied every model of how magnetic fields behave in interstellar space. At one point, the spacecraft's instruments recorded what appeared to be a directional force gently pushing against the probe, as if something invisible was trying to steer it or slow its progress. NASA has officially classified these readings as unexplained plasma interactions, but privately, researchers have noted that the data suggests Voyager might be passing through regions of space where electromagnetic laws operate differently than they do in our solar system. The implications are staggering. If space itself isn't uniform, if the vacuum between stars contains invisible structures and energy fields that follow unknown rules, then everything we think we know about the universe might be based on observations limited to our own cosmic neighborhood. Voyager might be humanity's first probe to encounter the edges of physics itself, regions where the fundamental forces that govern reality begin to shift and change. It's exploring not just empty space, but the boundaries of what we can even define as real. As disturbing as these discoveries from the edge of our solar system might be, they pale in comparison to what NASA found living in the vacuum of space itself, clinging to the outside of the International Space Station. In 2010, routine maintenance on the station's exterior revealed something that should have been impossible. Tiny bacterial colonies were thriving on the surface of solar panels, exposed to hard radiation, freezing temperatures, and the absolute vacuum of space. These weren't Earth bacteria that had somehow survived the journey to orbit. These were something else entirely. When samples were analyzed in both Russian and American laboratories, the results were consistent and terrifying. The genetic markers didn't match any known terrestrial life forms. The cellular structures were unlike anything in Earth's biological record, and somehow, these organisms were not just surviving in conditions that should destroy DNA instantly, they were actually thriving. The bacteria replicated slowly but steadily in the vacuum of space. Their cellular membranes didn't break down under constant ultraviolet bombardment. Most disturbing of all, their metabolic processes didn't follow any known biological pathways. It was as if they had evolved under completely different chemical rules. When researchers brought samples back to Earth for further study, the bacteria began to deteriorate. Under normal gravity and atmospheric pressure, their cell walls would collapse, as if they were suffocating in the very conditions that support all Earth life. These organisms seemed specifically adapted to exist in the vacuum of space. The implications couldn't be ignored. Either these bacteria had mutated from Earth organisms so rapidly and completely that they had become an entirely new form of life, or they had come from somewhere else. Somewhere where life operates according to biological principles we've never encountered. NASA has remained diplomatically silent about the possibility of extraterrestrial origin, but independent laboratories have confirmed the findings. These organisms exist. They survive in conditions that should be lethal to any life form we understand. And they suggest that biology, like physics, might operate very differently beyond the protective bubble of our planet's atmosphere. The discovery of space-adapted bacteria forced scientists to reconsider fundamental assumptions about where life can exist and how it can evolve. But another NASA finding challenged something even more basic, our understanding of chemistry itself. When the Cassini spacecraft explored Saturn's moon Titan, it discovered vast lakes and seas filled with liquid methane and ethane. On Earth, these are gases that we burn for fuel. On Titan's frozen surface, they form bodies of liquid stretching for hundreds of miles across the landscape. This discovery was strange enough, but Cassini's instruments detected something that made no chemical sense. The methane levels on Titan's surface should have evaporated into the atmosphere millions of years ago. Yet they persist, constantly replenished by some unknown process that keeps the moon's hydrocarbon cycle running like a perfectly tuned engine. Scientists searched for methane volcanoes or underground reservoirs that might explain the constant replenishment. They found neither. Instead, they discovered that hydrogen was mysteriously disappearing from Titan's surface atmosphere, as if something were consuming it. On Earth, certain microorganisms use hydrogen and methane as energy sources, breathing these gases instead of oxygen. The chemical signatures on Titan suggested something remarkably similar might be occurring, a form of metabolism that operates on alien biochemistry but follows recognizable patterns. The methane itself behaved oddly, absorbing and reflecting sunlight in ways that suggested ongoing chemical reactions no one could identify. Cassini's final measurements before the probe was destroyed revealed density changes and electromagnetic pulses that implied movement and activity across Titan's surface. Some scientists now believe that Titan's entire surface might function as a single massive ecosystem, a chemical engine running on thermodynamics that have no equivalent on Earth. The moon might not just harbour alien life, it might be alien life, an entire world that breathes methane and drinks hydrogen according to biological rules we're only beginning to glimpse. These discoveries paint a picture of a universe far stranger and more diverse than our Earth-based science has prepared us to understand. From particles that ignore thermodynamics, to bacteria that thrive in vacuum, to entire worlds that might be alive, NASA has consistently found evidence that the cosmos operates according to principles we're only beginning to discover. But perhaps the most disturbing discovery of all came not from distant space, but from right beneath our feet, challenging our most fundamental assumptions about the nature of reality itself. Most fundamental assumptions about the nature of reality. In 2020, NASA's Antarctic experiment detected something that shattered every rule in the physics handbook. The Antarctic Impulsive Transient Antenna Project was designed to catch cosmic rays streaming down from space, high-energy particles that constantly bombard our planet from distant galaxies. Instead, it discovered particles shooting upward from the Earth itself. This should be completely impossible. Cosmic rays can't pass through solid rock. They get absorbed by matter, stopped cold by the planet's mass. Yet the instruments were picking up clear signals of high-energy neutrinos emerging from below, travelling as if the entire Earth was nothing more than empty space. NASA scientists checked everything twice: the equipment, the data, the atmospheric interference patterns. The results remained unchanged. Particles were somehow emerging from the planet, moving in ways that suggested they were traveling backward through time itself, or operating according to physics that run in reverse. One interpretation that keeps physicists awake at night is that these particles might be visitors from a parallel universe where the fundamental laws operate differently, where time flows backward and matter behaves according to mirror image rules. Another possibility is even more unsettling, that we're witnessing the first evidence of unknown particles that interact with gravity and space-time in ways our current understanding can't accommodate. The discovery wasn't isolated. Other experiments have since confirmed similar anomalies, high-energy particles that seem immune to radioactive decay, moving through solid rock as if it doesn't exist, bending around magnetic fields that should stop them cold, and ignoring thermodynamic limits that govern every other form of matter we've observed. NASA's official response has been carefully diplomatic, describing these as unexplained high-energy neutrino events. But that's government speak for admitting that physics broke and no one knows how to fix it. If these particles really are visitors from another universe, then technically NASA has already made first contact with beings from a realm where reality operates according to completely different rules. The implications ripple through everything we think we understand about existence itself. If particles can cross between universes, if the barriers between different versions of reality are permeable, then our cosmos might be just one layer in an infinite stack of worlds operating on their own unique versions of physics. But even this mind-bending discovery pales beside NASA's most persistent and troubling mystery, one that's been quietly haunting the space program for over 50 years. When Pioneer 10 launched in 1972, it became humanity's first messenger to the stars, carrying a golden plaque designed to tell any alien civilization who built it and where we live. The probe was supposed to be utterly predictable. Scientists knew its exact mass, fuel consumption, trajectory, and speed. Newton's laws had this completely figured out. Decades later, when researchers checked Pioneer's position, they discovered something that made them question whether they understood motion at all. The probe wasn't where it should have been. It was slowing down by a tiny but measurable amount that defied every known force in the universe. The deceleration didn't match solar radiation pressure, cosmic dust friction, or gravitational influences. It was as if something invisible was gently tugging on the spacecraft from behind, whispering through the vacuum that maybe the universe doesn't follow the neat mathematical rules we've spent centuries perfecting. Even stranger, Pioneer's spin stabilization, which keeps the probe oriented correctly, refused to decay as expected. Most spinning objects in space gradually lose momentum and tumble out of control. Pioneer just kept rotating with mechanical precision, like a cosmic top that had forgotten how to stop. NASA engineers built detailed computer models, ran countless simulations, and calculated every possible force that could affect the spacecraft. They considered thermal radiation bouncing off the probe's antenna, microscopic impacts from interstellar dust, even the tiny pressure exerted by photons streaming from the spacecraft's radioactive power source. The numbers almost added up, but not quite. There remained a small, constant force that couldn't be explained by any known physics. Something was acting on Pioneer 10 that existed outside our current understanding of how objects move through space. The same anomaly appeared in Pioneer 11, Ulysses, and even New Horizons. Each spacecraft experienced tiny but consistent deviations from predicted behavior, as if space itself contained invisible currents that could nudge massive objects off their calculated paths. Today, Pioneer 10 continues its eternal journey toward the constellation Taurus, over 12 billion kilometers from Earth. Its transmitter went silent years ago, but its strange behavior continues to haunt scientists who study orbital mechanics. It's become a ghost ship drifting through the cosmos, proof that even in the apparent emptiness of space, forces exist that can bend the most fundamental laws of motion. The Pioneer anomaly represents something deeply unsettling about our relationship with the universe. We've built our entire understanding of physics on the assumption that the same rules apply everywhere. that motion and gravity and energy behave consistently throughout the cosmos. Pioneer suggests that assumption might be wrong. Perhaps space isn't empty. Perhaps it contains structures and fields and currents we can't detect from Earth. Perhaps the universe operates on layers of reality we haven't discovered yet. Invisible dimensions where different versions of physics leak through and occasionally nudge our spacecraft in directions they shouldn't go. Or perhaps Pioneer is simply the first human-made object to travel far enough from our solar system to encounter regions where the constants of physics themselves begin to shift and change, where the rules we've discovered through centuries of Earth-based experimentation start to break down and reveal their true nature as local phenomena rather than universal laws. These 10 discoveries represent more than scientific curiosities or measurement errors. They're windows into a universe that refuses to behave according to our expectations. Each anomaly builds on the others, creating a picture of reality that's far stranger and more complex than our textbooks suggest. The dust that acts like it's alive, the rocks that age in reverse, the metal that seems engineered, the particles that ignore thermodynamics, the energy that hums at the edge of space, the bacteria that thrive in vacuum, the chemistry that runs on alien rules, the particles from other universes, and the spacecraft that won't follow Newton's laws, all point to the same disturbing conclusion. We don't understand how our universe actually works. We've built our science on observations made from a single planet orbiting one star in a galaxy containing hundreds of billions of others. We've assumed that the physics we observe in our tiny corner of existence apply everywhere else, but NASA's discoveries suggest that assumption might be dangerously naive. The universe appears to be far more diverse, far more complex, and far more mysterious than we've dared to imagine. Different regions of space might operate according to different rules. Different scales of reality might follow different versions of physics. Different dimensions might bleed through into our own, carrying particles and forces that don't belong in our version of existence. What's most unsettling isn't just that these discoveries defy our current understanding, but that they do so consistently. This isn't random chaos or measurement error. It's evidence of underlying order that we haven't learned to recognize yet. Patterns that operate according to logic we haven't developed the tools to understand. NASA has spent decades quietly cataloging these anomalies, filing reports that challenge everything we think we know about reality. Some findings have been classified, others buried in technical journals that few people read. But the evidence continues to accumulate, building a case that our universe is far stranger than we've been willing to admit. The implications extend far beyond academic physics. If reality operates according to rules we don't understand, if different regions of space follow different laws, if particles can cross between parallel universes, then everything we think we know about existence itself might need to be reconsidered. These discoveries force us to confront the possibility that we're living in a cosmos that's far more mysterious, far more complex, and far more wonderful than our limited Earth-based perspective has allowed us to recognize. And NASA has the data to prove it. Perhaps the most chilling aspect of these discoveries isn't what they reveal about the universe, but what they suggest about the limits of human knowledge itself. Each anomaly NASA has uncovered represents a crack in the foundation of everything we thought was solid, unshakable scientific truth. Consider what this means for our species. We've spent centuries building civilization on the assumption that we understand the basic rules governing reality. Our technology, our space programs, our entire approach to exploring the cosmos rests on principles we now know might be incomplete at best, completely wrong at worst. The lunar dust that clings like it's hunting for something to attach to. The Martian rocks that seem to exist in multiple time periods simultaneously. The asteroid metals that appear manufactured by processes we can't duplicate. These aren't just scientific curiosities anymore. They're evidence that we're children playing with toys in a universe designed by minds we can't comprehend. What's particularly disturbing is the pattern of suppression surrounding some of these discoveries. Certain findings get buried in classified reports. Others disappear into technical journals that only a handful of specialists ever read. The public hears sanitized versions that downplay the truly revolutionary implications. Why? Because admitting that our fundamental understanding of physics might be wrong would undermine everything from our energy systems to our space exploration programs. It would force us to acknowledge that we're not the masters of scientific understanding we pretend to be. We're barely scratching the surface of a reality so complex it makes our best theories look like cave paintings. The space bacteria thriving in conditions that should kill any known life form. The methane cycles on Titan that suggest an entire world might be a living organism. The particles shooting up from Earth that seem to be traveling backward through time. Each discovery builds on the others, creating a picture of existence that's almost too strange to accept. But accept it we must, because the evidence keeps mounting. NASA's instruments don't lie. The measurements are consistent across decades of observation. The anomalies persist despite every attempt to explain them away using conventional physics. What we're witnessing might be humanity's first glimpse of the true nature of reality. A cosmos where different regions operate according to different rules, where life can exist in forms we never imagined possible, where time itself might be more flexible than we assumed, where the boundaries between universes might be more porous than we dared to believe. The particles from interstellar space that defy thermodynamics suggest that the void between stars isn't empty at all. It's filled with phenomena operating according to principles we haven't discovered yet. The strange energy signatures Voyager detected at the edge of our solar system hint at invisible structures governing space itself. These discoveries force us to reconsider not just what we know, but what we think we can know. If reality operates according to rules that change depending on location, scale, and conditions we can't control, then the dream of a unified theory of everything might be fundamentally misguided. Maybe there is no single set of physical laws governing the universe. Maybe reality is far more diverse, far more creative, far more willing to break its own rules than we've been prepared to acknowledge. Maybe what we call the laws of physics are just local customs that apply to our tiny corner of an infinite, impossibly complex cosmos. The Pioneer spacecraft, still tumbling through interstellar space with a mysterious force gently slowing its progress, represents more than an engineering puzzle. It's a message from the universe itself, telling us that we don't understand motion, energy, or space as well as we thought we did. That message should humble us. It should make us question every assumption we've built our civilization upon. But it should also excite us, because it means the universe is far more interesting, far more mysterious, and far more full of possibilities than our current science allows us to imagine. NASA's impossible discoveries aren't just challenging our physics textbooks. They're opening doors to entirely new ways of thinking about existence itself. They're showing us that reality might be more like a vast multidimensional artwork than a simple machine governed by predictable rules. The dust that seems alive, the rocks that age backward, the metals that appear engineered, the particles that ignore our chemistry, the energy that hums in empty space, the life that thrives in vacuum, the worlds that might be organisms, the visitors from parallel universes, and the spacecraft that won't obey Newton's laws are all pieces of a puzzle we're only beginning to recognize. That puzzle might be showing us our first glimpse of what the universe actually is beneath the simplified models we've constructed to make sense of our observations. It might be revealing layers of reality we never suspected existed. It might be demonstrating that existence itself is far stranger, far more wonderful, and far more mysterious than we ever dared to dream. These 10 discoveries represent more than scientific anomalies. They represent an invitation to expand our understanding of what's possible, to question what we think we know, to remain humble in the face of a cosmos that consistently surprises us with its creativity and complexity. NASA has given us a gift that's both terrifying and exhilarating, They've shown us that we live in a universe where the impossible happens regularly, where physics breaks down and rebuilds itself according to rules we haven't learned yet, where reality itself might be far more flexible and far more amazing than our limited Earth-based perspective has allowed us to recognize. The question now isn't whether these discoveries will change our understanding of the universe. It's whether we're brave enough to follow where they lead. Whether we're willing to abandon comfortable assumptions and venture into territories where our current knowledge becomes useless and our sense of wonder becomes essential. Because if NASA's impossible discoveries teach us anything, it's that the universe doesn't care what we think is possible. It just keeps being impossible, consistently and beautifully, daring us to catch up with its infinite creativity and boundless mystery. So here we are, staring into the abyss of everything we thought we understood about reality. 10 discoveries that don't just challenge our physics textbooks, they obliterate them completely. We've journeyed from lunar dust that behaves like a living organism to particles that casually ignore the fundamental barriers between universes. What connects all these impossible findings isn't coincidence or measurement error. It's evidence of a universe so much stranger and more complex than we ever imagined that our current science looks like finger painting compared to a masterpiece we can't even begin to comprehend. Think about what this means for humanity. We've built our entire technological civilization on the assumption that we understand the basic rules governing reality. Our satellites orbit according to equations we trust. Our spacecraft navigate using mathematics we believe are universal. Our entire approach to exploring the cosmos rests on principles that NASA's own discoveries suggest might be incomplete at best. The most unsettling part isn't that these anomalies exist. It's that they exist consistently, systematically, as if the universe is trying to teach us something we're not quite ready to learn yet. Each discovery builds on the others, creating a picture of existence that's almost too extraordinary to accept, but too well documented to dismiss. These findings force us to confront an uncomfortable truth. We don't live in the predictable, well-ordered universe our textbooks describe. We live in something far more mysterious, far more creative, and far more willing to break its own rules than we've been prepared to acknowledge. A cosmos where different regions might operate according to different physics, where life can thrive in conditions that should be impossible, where time itself might be more flexible than we assumed. NASA hasn't just found 10 things that defy physics. They found evidence that physics itself might be far more diverse, far more complex, and far more wonderful than our Earth-based observations have allowed us to recognize. They've shown us that we're not the masters of scientific understanding we pretend to be. We're explorers, taking our first tentative steps into a reality so vast and strange that our current knowledge represents barely a whisper of what's actually out there. But that's not terrifying. That's exhilarating. Because it means the universe is far more interesting than we ever dared to imagine. It means there are discoveries waiting that will make these impossible findings look simple by comparison. It means we're living in a cosmos where wonder is not just possible, it's inevitable. The next time you look up at the night sky, remember that out there, dust is acting alive, rocks are aging backward, metals are defying formation, particles are traveling between universes, and spacecraft are being gently nudged by forces we can't even name. Remember that reality itself might be far stranger, far more beautiful, and far more impossible than we've been brave enough to believe. NASA has given us the greatest gift any space agency could provide. They've shown us that we live in a universe where the impossible happens every day, where mystery isn't the absence of knowledge, it's the presence of infinite possibility. And that's just the beginning.